Okay, my phone is telling me it's the top of the hour, so why don't we get started? Welcome everyone to the next webinar that we're having to help people learn SolidWorks for use with your FIRST Robotics competitions. Today we're going to be talking about applied features, and I'll get more into what those are in just a little bit. First, let me introduce myself. So my name is Joe Russo, and I'm the Learning Experience Director for SolidWorks. I'm a CSWE, and I've been working here at SolidWorks for 28 years now. This is the second in our series. Earlier this week, Dave Bassinet, one of my colleagues, had a chance to teach you about sketches and features, showing you how you could start with 2D sketches and build them up through base extrude, boss extrude, and cut extrudes to create solid geometry. And today I'll be covering applied features, and in the upcoming weeks, we have more topics for you. We will be recording these webinars and we'll share them with you after the series is complete. Okay, so today we're going to be talking about applied features. So as I mentioned earlier, a sketch-based feature like a base extrude, you have to start with a 2D sketch. You create your profile and then you extrude it, or you can use it for a revolve or a sweep or a loft. Those types of features are sketch-based features. Applied features do not need a sketch. So applied features, you select existing geometry and you make modifications to that geometry. So you select existing faces, edges, vertices, features, and then you perform operations on those. As you can see here on the KitBot model from FRC 2025, there are a number of interesting instances where we can use applied features. So I'm going to go through each of these over the course of the webinar to teach you a little bit about how to use each feature. The first one that I'm going to show you is for this bracket that's here in the corner of KitBot. And I'm going to show you how to start with sharp edges and round them off to nice smooth corners. Let's switch over to SolidWorks. Okay, so here we have the part with its nice sharp edges. First thing that I'm going to do is turn on my selection filters. And I use the F5 key to turn the toolbar on and off. Why am I doing that? Because I want to get these small edges, and they're tough to get. Sometimes I get a vertex, sometimes I get a face, sometimes I get the wrong edge. I'm going to use the edge selection filter. So now notice I can't get a face, I can't get a vertex, I can only get edges. Okay, with that turned on, let's start my fillet tool. It's right here on my features toolbar on my command manager. Fillet, and I want a constant radius fillet. So I'm going to select that option. And now I want to go and try to pick the edges that I want. Well, what happens if I pick the wrong edge? That often happens. These are small edges. Well, you can just come over here, right click and delete that selection. So if you've already picked 7 edges and you misclick on the 8th, you don't have to start over. Just right click and delete. I see that all the time when I teach people how to use fillets. So I want to do the 6 edges around this part. So I'm going to pick this edge and maybe this edge. And I could go around and pick all of them, but that can be a little tedious. I'd have to rotate and zoom. Let me show you a really cool feature of SolidWorks. I'm going to clear my selections, pick one of my edges, and now I get this toolbar. And this toolbar gives me intelligent options for other edges and other selections I might want to fillet. As I move over, you can see those various edges highlight. Well, that's definitely too many. I don't want to fillet the holes. But this first option here, looking at the purple highlights all around, that's exactly what I want. So I'm going to say OK to that. So now I have my 6 edges selected around my part. I have to set the size that I want, and I want this to be a 1/8 inch. So I can type it as a fraction, 1/8, and then I put the inch symbol. And when I click off, it calculates the correct in the document units. Notice I'm in inch pound seconds. It does it right for me into inches. I think that's everything I need. Let me click OK. And there we go. My first constant radius fillet for this webinar is done. A lot easier with that selection toolbar, and a lot easier because it can calculate the values for you. Pretty easy start. Let me show you another example of constant radius fillets. Here I'm going to use this T-bracket where I have these sharp inside edges, and it's going to turn it into these big rounds here. You can see those on Kitbot right here to help with the supports. So let me bring my next part over. So earlier, when we created the constant radius fillet, it rounded these outside sharp edges, but the same tool can be used to round these inside edges as well and add material. So I'll go back to fillet, same tool, constant size fillet, and this time I want to pick this edge, and I notice I need my selection filter on, so that way I make sure I'm only picking edges. So I pick one edge, and then I'm going to come over here and pick the other edge. Rotate that back so we can see it. And this time I need a 1 inch. So because I'm in inch-pound seconds, I can just type 1, and it knows to put it into inches. Now notice I'm not getting a preview this time. Earlier we saw that purple preview. That's because up here under my preview options, it's currently set to no preview. I could change it to full preview, so then I know I've selected the correct edges. Everything looks good. I will click OK. And there we go, a different type of fillet that adds material, unlike the earlier fillet that rounded and took away material off of those sharp edges. Okay, let me show you my next example. So here we have the strap that holds the battery in place, and I'm going to talk about rounding off these corners here on these sharp edges. And sometimes you can't use the constant radius fillet, and I'm going to show you an example here. Okay, so here we have our part with all of our sharp edges. And I'm going to show you 2 instances of adding the constant radius fillet. So I'm going to come here for items to fillet, make sure I have the correct fillet type. In one case, I'm just going to pick the outside edge. I'm not going to pick the inside edge because I want to make a point, and then you'll see it in just a moment. And then in the other instance, I'm going to pick this inside edge, and the corresponding outside edge. And I'm going to add a 1/8 inch fillet. And notice, because I'm in millimeters grams second, SolidWorks is smart enough to convert the fraction 1/8 and then the quotes for inch over to millimeters. Let's click OK. And let's take a look at this from the front. Oh, that does not seem to have done what I wanted to, a nice, smooth, consistent width corner. When I only selected the outside edge of this thin body, it didn't round off the inside edge as well. And when I did this corner as 2 separate fillets, it applied the proper radius at each corner, but notice it comes down and almost bulges at the corner and then goes back to its normal width. That's not what we wanted. So I think I'm going to remove that fillet. Sorry, fillet, it was a good try. And I'm going to show you a better way to achieve that when you have a thin body like this. In this case, let's edit the sketch. And I'm going to use sketch fillets instead. So that's this button right here on the sketch tab. I want it to be 1/8 of an inch. And then for entities to fillet, I'm going to click at the vertices where I want to add that fillet. I will click OK. And then that gets out of the fillet command. Then that gets out of the sketch. And now let's take a look. Now that's a pretty solid body. Consistent thickness the whole way through the corner. Did both the outside edge and the inside edge on this corner over here. That's the geometry I want. So I show you this as a cautionary tale that even though I think constant radius fillets are very easy to use, they aren't always the solution for you. And sometimes you need to use a sketch fillet or other options. I have one more fillet example that I want to show you. On the end of the battery strap, we want to round this 3-sided face off to a nice round, full round fillet here. Let me show you how that's done. I should pause here and just tell you what this message is all about. When you drag one part into another part window, it's not sure if you're trying to make a derived part or if you're trying to add the new solid body into the existing solid body. I'm not, I just am not closing the old part before I open the new one. So I will just simply answer no. But that's what this message is all about. Okay, so here's another example of the battery strap, and we're going to try it first with constant radius fillets. They've been working well for us, so let's try it. I'm going to turn on the fillet tool, constant radius, and what I want to fillet is this edge and this edge, and it needs to be 5 millimeters. And I know that because this length here is 10 millimeters, so half of it will get me halfway there. Let's see what happens when I do that fillet. Oh, that looks pretty good from this angle. Wait, what's that? Oh, there's a seam at the top because when this fillet connects to this fillet, it creates a seam or an edge there. It's not quite as smooth as we'd like. And in fact, I have Instant 3D turned on right now. So let me click on this body and I'm going to make it wider because I can change it just by dragging when I have Instant 3D on. Oh no, that's definitely not what we wanted. This is not a full round across the top. It's adding this flat face in between because it's a 5 millimeter constant radius fillet on one side and a 5 millimeter on the other. Nope, nope, nope. That was not what I wanted. So let me undo to get rid of that fillet and bring it back to 10 millimeters. Let me show you a better way to create this geometry. I'm going to turn on the fillet tool and I'm going to switch to this type of fillet, full round fillet. Notice when I do that, the property manager gets a lot simpler. It's looking only for a few things. It wants 3 faces, 3 sets of faces. So face set 1, I'm just going to pick this side. I could have picked the other side. Then what's the face in the middle? Well, that's this one. And what's the face on the other side? That's this face. And notice the preview rounds it off. But you might be asking, well, why didn't you have to type in a radius value? You had to for constant radius fillets. That's the beauty of full round fillets. It calculates the radius for you and removes that face in the middle with a round in between. Let me click OK. And let's do that same test we did earlier. I'm going to switch. I have Instant 3D on. I come here. I drag it out. No seam, no flat face. Full round fillet is parametric and understands it's supposed to completely round that middle face from this one to that one. Pretty cool tool. All right, that's what I had for you regarding fillets. I'm going to take a pause here and check in with Franco in case there's any questions from the audience.
Nope, none that you need to answer live. I've been answering them as they come in.
He's got fast fingers. Nice job, Franco. Thank you for keeping up with that.
We will be talking about resources though, later on in this webinar. So if anyone has any questions about where to download Kitbot or where to download First Resources, Joe will go over those after the presentation.
Perfect. You got a hook in them. They'll stay tuned. Thank you, Franco. All right, well, let's go see what's next. So we're done with fillets. Let's talk about patterns next. Okay, we're going to do a linear pattern first. That's the guardrail that you have here at the front of the bot. So let me bring my linear pattern part in here. No, I'm not making a derived part. And let's see what we're starting with. So we've got our sheet metal part. And by the way, that's what we're covering on next Tuesday. Franco, who's my co-host today, is going to be presenting next Tuesday all about sheet metal and weldments. So if you'd like to know how the sheet metal part was created, stay tuned. Franco will have a lot of information for you next week. Okay, so I have my sheet metal part and I have a single hole that's drilled from the top down all the way through. What I need though is I need a pattern of holes the whole way down the part. Let me show you how that can be done using one feature, linear pattern. That is right here. It's hiding right next to fillet. I'm going to go ahead and turn on linear pattern. And oh boy, there are a lot of options here in the property manager. We're going to choose a few of them and you'll see the feature is quite easy, but quite powerful, which is why it has all these choices for you. So the first thing that we need to do is set up the direction. Which way do you want this pattern to go? I could pick an edge, I could pick a face, I could pick a plane. Let's try that. I'm just going to pick the front plane for my first instance. Next, it's wondering how many do I want? Because it's under spacing and instances. I want to go every ½ inch, so 0.5 inch. And maybe I'll just start with 10, just so you can see, and that way I can edit it later and you can see that. Okay, now I still don't see anything, but that's because I haven't told it what I want to pattern yet, features and faces. So what I want to pattern, I can choose from this flyout feature manager tree, and I want to pattern the whole. Uh-oh, something seems to be wrong. My yellow preview is coming off the part. And that's because when I pick the front plane, it shows a direction normal to the plane. I need to reverse that direction. Easy to do. I could either do it here by clicking reverse direction, or right here graphically, I can reverse direction. So now I'm seeing my 10 instances on the body. Very nice. We're getting there. So how many instances do we think we need? Well, I could do some math, grab my calculator and figure it out. I could just keep increasing it until it fills up. Not exactly that good of an idea. And more importantly, not parametric. What if the length of this bumper ever changes? Even if I did fill it up, if it changes and gets longer, I would need more instances. So I've got a better way to handle that. That's a lot more robust. I'm going to change this to up to reference. And what it's looking for is some sort of reference, as you can see, a vertex, edge, face, or plane, where the pattern is going to stop. I'm going to do that by picking this back face. So there we go. Now it fills up the entire pattern. Turns out it was 53 instances. I knew that because I had done it before, but you wouldn't have known that. But it fills up the entire part. Okay, we're getting there. Next thing we want to do, though, is there's also a set of holes over here. It's not just one row of holes. I need a second row of holes. Well, luckily, linear patterns allow me to go in a second direction. So I'm going to come in here, and I'm going to turn on direction 2 by picking an edge this time. Last time I picked a plane. This time I picked an edge. Okay, and then notice the arrow is pointing away. Well, I needed to come over here, so I'm going to reverse direction. Last time I did it graphically, so this time I'm going to do it here in the property manager. And the spacing is 1 inch. 1 inch from there to here. I have the correct number of instances. Okay, we are almost there. Now, I'm going to make something up. This isn't something that actually exists on Kitbot, but it'll help you understand something you can do with patterns. What if in the middle of Kitbot there was some sort of sensor or some sort of motor, something you didn't want to drill through, something you didn't or couldn't place any fasteners through, and so you didn't want holes near the middle of this bracket? Well, in order to do that, we can use this instances, tough word to say, to skip option. And if I look at this directly from the top, view orientation top, and I'll zoom in here, instances to skip, there we go. I can choose one at a time. And when I click on them, they disappear. They're no longer part of the pattern. They're now listed here saying that they're being skipped. So if I made a mistake, I could bring them back by removing them from this list. Or I could also box select. So I can come here and grab all the ones that I wanted to, and it removes those as well. So now I have my protected area in the middle of my bracket where I'm not going to have any holes whatsoever. Okay, let me go back to isometric so we can see what this is going to look like. I think I have all of my options set. If not, I can always edit feature. So let me click OK. And actually, I got it right. We have all of our holes patterned in one direction this way, a second direction that way. It goes up to reference. So if this ever gets longer, we would add more holes, or if it gets shorter, we would take more holes away. And I used instances to skip to keep this protected area in the middle where we want to keep our protective sensor or motor or whatever is hiding under there. So that is linear patterns, many of the options inside there. I hope that was helpful. Let's take a look at what's next. Okay, next I'm going to do a couple of circular patterns for you. I'm going to start with a simple one. This is for the roller that we have here up on top of the intake. So let me bring my circular pattern part in. Okay, so in this case, we have a simple hole notch cut out here that we want to pattern. So I will turn on circular pattern, but when I come up here, I don't see it right away. Well, this drop down here is hiding a couple of the other pattern types that exist. And wow, there are a lot of them. So I'm going to be doing a circular pattern, but you can see all of the other ones that exist. I encourage you to experiment with them. They're quite powerful. But for this basic webinar, I'm just doing linear and circular pattern today. So I will turn on circular pattern. Just like before, it wants to know the direction in which you want to rotate. Well, here I'm not looking for a linear edge. I'm looking for something more circular. So I could choose a circular edge or a cylindrical face. So I'll try that. So that's going to be my axis of rotation, goes through the center of that cylinder. Next, it's wondering what faces that I want, what features or faces do I want to pattern. I could choose them here from the feature manager tree, but I did that last time. So let me show you that I can just select it right here in the feature, in the graphics area. Wow, it already populated a preview for me. How did it know how to do that? That's because of this equal spacing option where it's going 360 degrees, 6 total instances. Well, what if I change that down to 3 instances? Now you can see it would go every 120 degrees. Whereas if I did 6 instances, it's going every 60 degrees. Again, by having equal spacing on, much like the up to reference in linear pattern, it does some of the math for you. Okay, that's all I needed for that circular pattern. Let me click OK. Quite powerful. Let me just check. Yeah, I'm doing well on time, so let me take a quick detour here. I want to show you something. Remember that selection toolbar we used earlier in fillets? And I only showed you how it can pick 5 edges. I did want to show you that it's so much more powerful. Imagine if you wanted to round off all of these edges on this part and create a nice smooth roller wheel. Let me come back to fillet, back to constant radius. Under items to fillet, I'm just going to choose one edge. But notice all of the options that now appear here. All the way down to 99 edges it can auto-select for me on this simple part. On both sides, a nice smooth roller wheel now. So definitely use your selection toolbar when you're using fillets. Okay, but I digress. I'm supposed to be on pattern. So let me go back and do another circular pattern for you. Okay, so here we have the wheel. Oh, I forgot to show you on my slide. This is one of the 6 wheels that are down here at the bottom of KitBot. And I want to make a circular pattern. So I'll come here, I go down underneath pattern to pick circular pattern. For my direction, last time I picked a cylindrical face, so this time I'll pick a circular edge just to show you that it would work just the same. And for features and faces, last time I picked it in the graphics area, but this time I want to grab this one and these and 2 on the other side. It's just going to be so much easier if I just grab them right here from the Flyout Feature Manager tree. And equal spacing is turned on, 360 and 6 instances. I think that's everything I wanted. Let me click OK. And work looks good on this side. And notice these cuts don't go all the way through, which is why I also need the cuts on this side. Now you might be asking yourself, it seems like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 instances of this. But for your circular pattern, you only had 6 instances. What happened? How did this work? Well, as we look at this, the cuts on this side have a notch on the left to accommodate this circular boss, and the cuts on the right have a notch on this side to accommodate this circular boss. So what I did, instead of creating 12 instances of this cut, which would have been facing the wrong way half of the time, I made 6 instances of the pair of cuts, which is why we ended up with 12 instances. So just different ways you can make circular patterns. Okay, before I go on to shell features, I'm going to check in with Franco if we have any CAD questions regarding patterns or fillets.
We do have one that you might be able to answer is how do you auto select in the fillet option? I believe he's referring to pre-selection.
Okay. So what I'm going to do for that is I'll just I have this part open, so I'm just going to make this fillet. I can come in here and let's say I wanted to round these outside edges of these bosses. I could pre-select them one at a time and then go in and create my constant radius fillet.
And the
Obviously,
same works for a pattern. If they were selected for the pattern, they would pattern and automatically populate. I think that's what he was asking.
okay. Let me, for that, delete both of those. And what I'll do this time is I'm just going to do that one cut. So I'm going to pre-select before I go into circular pattern. And I don't get a preview because it doesn't know where I want to pattern it yet. But as soon as I pick my edge, it already knew which feature or face that I wanted to do. So yes, pre-selection works for circular pattern as well. Any others right now, Franco, or should I go on to shell features?
No, I think we're good for right now.
Okay. So now shell features. I will readily admit that if you open up Kitbot, download it from the FRC website and look at it, this isn't a shell feature. It's actually 3 pieces of polycarbonate that are zip tied together. But I just thought it was too perfect of an example and something where you might be able to use shell. You could design it the way I'm going to show you. So if you download this, you'll see that I made a little bit of an adjustment here. But what I want to do is take this box and turn it into this polycarbonate shell. Notice that the sides are a little bit longer than the top. I have a way to take care of that. Let me show you how this works. Okay, so I have my box here. It's just a solid box that I extruded. And right here is our shell feature. To create a shell, what I need to do is tell it what faces I want to remove. So I'm going to start by just removing one face because I want to start simple if you haven't seen shell before, and I'll click OK. And all it did was remove and hollow out the part, taking away that one face that I dragged or that I selected. That's good, but not what I had in mind. So I'm going to right click on the feature in the feature tree and choose this first option, Edit Feature. That'll give me a chance to come back in here and modify that existing feature. And now what I want to do is add additional faces that I want to remove. So I choose this face and this face. I also want to take out the back face and even the bottom. Because when I'm done, all those light blue faces are going to go away and I'll be left with the side, the top, and the other side. There it is. That would be a nice shell to put right on top of Kitbot to protect the intakes. Now, how did I do that? If it was a simple boss extrude, how did I remove just part of the top of the face? Let me walk you through what I did. So here's the simple boss extrude. Just a rectangle extruded in one direction. But then I used the split line feature where I sketched 1.25 inches from this edge. I sketched a line. Then I used symmetry to mirror that sketch entity to 1.25 inches from the other side. And then I used the split line feature to project that sketch down onto the face to create 2 new edges. It did not project the construction line. It only projected the sketch geometry. And as you can see, that split it into multiple faces. So then I was able to remove those faces when I was doing my shell feature. A little beyond the basics for a second webinar in this series, but I wanted to show you how I did it, just so you didn't think I was performing a little bit of magic. Okay, let me go back over. I have one more feature to show you. This is the draft feature. You can see that on these round bosses on the inside hub of the wheel, we added a little bit of a taper. So let me show you how that is done. So right now, these are nice and straight. Same diameter here as up here. But oftentimes you need to add taper or draft, as they call it in Solidworks, if you're extracting something from a mold. If you're trying to pull it out of a mold, it's easier if it angles in as it goes away from the direction of pull. So let's use a draft feature here to do that. I'm going to go ahead and turn on draft. It's right here on the features command manager. And the first thing it's looking for is a neutral plane. That's where the draft feature starts at. That's where there would be no draft applied. So I want it to be at the base of these spokes. So I can choose any one of these faces because they're all coplanar, so they all would act the same way. So I'll just pick this one. Next, it wants to know what faces that I want to taper. I'm going to go ahead and pick the 6 faces. Looking good so far. Now on Kitbot, they actually use 1 degree, but I'm going to start by showing you 3 degrees just because that'll make it a little bit more visual for you. And let me click OK. And notice what's happened. From the neutral plane, the diameter remained the same. But as you move farther away, those faces taper in by 3 degrees, the value that we typed into the property manager. Now in Kitbot, they're actually 1 degree. So I'm going to come back and edit the feature and change the draft angle to 1. And that's how it works in Kitbot. Now that's obviously only the draft on one side of these. There are spokes on the other side as well. I would have to do it again on that side. Do you think I could do it in the same feature? Actually, I can't. I would have to do it as a second feature. And why is that? If I choose this as my neutral plane, everything as I move away from it gets narrower on this side. But everything on the other side would get wider if the neutral plane was reversed. So if I used this all-in-one feature and I tried to go in 2 separate directions, it wouldn't work. I'd get narrower on one side, wider on the other. And I can demonstrate that quickly for you here. What if I reverse the direction of my neutral plane? And again, I'm going to set it up to 3 degrees just so it's more visual. And click OK. Now, again, at the neutral plane, the diameter doesn't change, but as I move away, it gets wider because I reversed direction this time. I changed the direction of pull relative to my neutral plane. Obviously, this is not what I want, so let me just set it back real fast. I don't want to leave bad geometry behind. There we go. Okay, before I go on to some of the resources, Franco, any CAD questions?
Um, no, the only one that I have that I don't know the answer to directly is how do they install SOLIDWORKS through the Champion license? I don't think that's within the scope of this webinar, so I
Yes, unfortunately not.
yeah.
Okay, so let me start covering some of the resources, and then Franco, you can tell me if I hit all of our Q&A. This webinar series only scratches the surface of how you can learn SolidWorks. There are so many other ways for you to learn that my team and others have provided. On the left, we have a QR code that takes you directly to my SolidWorks training. We have over 400 lessons sorted into over 100 learning paths, from basic sketching, CSWA prep courses, CSWP prep courses, even some simulation, electrical routing, and more. All of it is available for free to you as a SolidWorks student. If you have a student license, when you log in, it'll recognize you, and you'll be able to take all of the content there for free. The column here in the middle, we have a number of practice problems available for you. Let's say you just want to practice modeling and you want to try to make this part, and you need to know exactly what its height, length, width, and so on, any key views, things like that. We have 250 practice problems for the CSWA exam available to you, and soon we're going to be adding another 115 that will help prepare you for CSWP. So these practice problems are great homework assignments, great practice. And then over here, classroom curriculum. If you're a mentor or a teacher and you're wondering how you can teach SolidWorks in class, we have a number of resources here that teachers can use to bring SolidWorks into the classroom. So please check these out if you're looking for more learning content beyond this webinar. If you are a FIRST Robotics team, and actually, let me try something here. I'm going to attempt to start one of the polls that we have. Okay, I just launched a poll. I am curious if you currently use SolidWorks, and I'm also curious if you're currently a member of a FIRST Robotics team. Because this is trying to help you learn SolidWorks at some of the basics. So if you don't use SolidWorks today, that's okay. We're trying to give you some more knowledge. And also, we're trying to promote our FIRST Robotics offerings. So it's nice to find out. So I'm just going to move that to my other screen and talk about this slide and give you a chance to continue to answer. So what do we have for FIRST Robotics teams? Well, if you're a member of a team, we have free software for you. You can use SolidWorks software, whether it be SolidWorks Desktop or SolidWorks X Design, to design your robot. We also have kit of parts so you can assemble your robot much easier, and a lot of learning resources. So that QR code will take you directly to the FIRST Robotics page. All right, thank you very much for those that have answered the poll. Actually, I just saw a few more resources or a few more answers coming in, so I'm going to leave it up there for another minute. Let me talk about the last item, certification vouchers. So if you've never heard of it, we have the Certified SolidWorks Associate, the CSWA exam. It's the basic level CAD that demonstrates a good amount of knowledge of the software. If you can pass CSWA, you understand sketching, extrusion, applied features, everything I showed you today, and basic assemblies that you're going to learn in a couple of webinars from now. If you attend all 6 of these FIRST Robotics webinars, you will receive a free CSWA voucher. We will download the registration report and find out who attended, and we'll compare all 6 webinars. If your name and your email show up in all 6, our SolidWorks EDU marketing team and certification team will reach out to you late August or early September to provide your voucher to you so you can take CSWA. All right, I'm going to end the poll. Thank you to everyone who answered. And I believe, other than previewing upcoming webinars, that's it. So Franco, let me send it back to you, see what we have for questions.
A lot of questions came in that they missed the first session. And if they watch the review, are they eligible for the CSWA voucher? I believe the answer is no, but
I also believe the answer is no, because when we post the recording, we will have no way of knowing who watched the recording. It most likely is going to be posted on YouTube, most likely at the Solidworks channel, but I don't know that for sure. And when we do post it, if we don't have a way to track who watched it, we won't be able to find out who watched all 6. It had to be live attendance for this. Might not be the answer people wanted, but that's the best answer we have.
A lot of people are asking how to join a first team. I sent out in the answers there is the link for the FIRST Robotics. It's www.firstinspires.org. You can join teams. You can find teams near you. Yeah, this and someone was saying that the QR code didn't work for them, but I just tested it out and it does work. So
Okay.
what we can do is when we post these, we can probably post the links as well.
Yes. But you should be able to look up first, as you can see, it's even trademarked. First robots, first teams, first robotics. You will certainly find teams. Any other questions?
Uh, Lots of thank yous, lots of good jobs. Um,
Excellent. Well, let me preview the ones coming up next. So, Franco, since you're next, do you want to give a quick preview of what you're going to be talking about next Tuesday?
sure. So next week I'll be talking about sheet metal and weldments. It'll be building on the first 2 webinars. So sketches, we'll be doing some sketching. We'll be doing some applied features as well. And for sheet metal, we'll get to show how we can make flat patterns and export them to cutting machines. Weldments, I'll show you how to save some time, making welded frames and using standard profiles using for welded frames.
Excellent. So tune in next Tuesday for that webinar. If you're wondering where to find it, Franco, I don't know if in the Q&A you shared the links to the other ones, but if not, wherever you found out about this one from SolidWorks EDU marketing team, they hopefully have advertised and will continue to advertise the other 6, the other 4 that remain. Okay, with that, I believe we are done. Franco, thank you very much for doing the Q&A panel.
Yep.
Attendees, thank you so
There's
much for coming and learning a little bit more about SolidWorks and FIRST Robotics today.